Excellent. Okay. Well, listen, I appreciate the opportunity to speak today. I'm going to talk about something a little bit different. I mean, it is about CBDC and DeFi, but I think that it's really important that when we're talking about these two important subjects, that we understand the issues and challenges that are related to interoperability. So I'm going to focus my remarks today on this topic and highlight how all of this is interconnected. Now, there are a lot of ways to think about interoperability, but one aspect that I want to touch upon today is the idea of building bridges between blockchains. Um, so in order to understand the importance of bridges, it's important to look at Bitcoin and Ethereum, which we're all, I assume, are very familiar with. So, you know, and the last decade has proven unequivocally that Bitcoin is overwhelmingly popular, representing about 80% of the total market cap of cryptocurrencies. But its base code has a relatively narrow feature set, and it does not support smart contracts, which means that it doesn't support the decentralized applications like DeFi that we're talking about here today, which are available on other blockchains such as Ethereum. So indeed, you know, Bitcoin and Ethereum operate on two different and distinct blockchains. You know, essentially, they only really care about verifying transactions on their respective chains, apologies, which necessitates a custom-built cross-chain architecture to allow for the transfer of information between these chains. So in other words, if a Bitcoin user wanted to take advantage of a DeFi app on Ethereum, she would need access to a bridge between the two chains. But these bridges are extremely difficult to build in a decentralized and trustless environment. So, you know, in order to build a trustless bridge between Bitcoin and Ethereum, the protocol will need to verify the state of the chain to which it's connecting, just to ensure that the accuracy and legitimacy of that transaction. You know, but the fact that blockchains have been growing steadily makes it harder and harder for resource constrained devices, especially mobile devices like mobile phones, to do a full sync and to thus verify the state of that chain. So as you can see in the chart here, the Bitcoin blockchain has increased significantly in the past few years and is now more than 280 gigabytes. In fact, I think this data is a little bit old, and I think the number is over 300 gigabytes now, and I believe Ethereum is even higher. So basically what that means is if you want to create a bridge from Bitcoin to Ethereum, you essentially have to recreate the Bitcoin blockchain on Ethereum, which effectively doubles the size of that chain to more than 600 gigabytes. Now, there are ways to reduce the data needs using what's called a simple payment verification technique. And that essentially means that you just need to only download the headers of a chain. But unfortunately, the amount of header data needed to sync in this fashion is still significant. For Bitcoin, I believe it's about 50 megabytes, and for Ethereum, it's about 5 gigabytes of data. So what that means is that given the amount of data needed and the high gas fees associated with Ethereum, it's simply too expensive to maintain such a bridge. So what does this have to do then with CBDC? Well, you know, it's highly likely that most central banks are contemplating, you know, the issuance of CBDC, are envisioning that it will be done on a private network, which may or may not utilize blockchain technology. It's also likely that this private network will not produce a significant amount of these dApps that provide utility for many people. So as with Bitcoin, users of this CBDC will also desire a bridge to public blockchains like Ethereum, where they can access these DeFi apps and other use cases. But again, as we've noted, in order to do that, the issue is, you know, building bridges. You have to create interoperability, and that still needs to be addressed. So as Xiaoshen mentioned, I work on a project called Celo. And so in order to solve this problem, the team working on Celo, which is an open source blockchain, much like Ethereum, it actually has its roots in Ethereum. In order to solve this problem, The team working on Celo has been focused on two key initiatives. Developing an open source light client, which we call Plumo, and supporting the development of another open source project called TBTC, which will allow people to use Bitcoin safely in DeFi apps on both Celo and Ethereum. Now, the light client we've developed uses innovations including epoch-based syncing, BLS signature aggregation, and zero-knowledge snark proofs to reduce the amount of data necessary to verify the state of a blockchain. In fact, our light client is about 100,000 times lighter than Bitcoin and 11 million times lighter than Ethereum. So making the idea of building bridges much more attainable and affordable. Additionally, we're excited to announce the integration of TBTC with the Celo network. This integration effectively builds a bridge between the Bitcoin and Celo public blockchains, allowing users to simultaneously hold Bitcoin and use it for any application, including DeFi, within the Celo ecosystem. And with the innovations developed in our light client, it also means that transactions between Bitcoin and Celo will be significantly faster and cheaper than Ethereum. As central banks around the world start to contemplate the issue of CBDC, we hope the innovations we're building on Celo will help build these bridges between CBDC and public DeFi applications. So I will stop there. I want to thank you for your time. I'm happy to address any questions you might have, and I look forward to a further discussion on this topic. So, thank you.
Thank you very much, Ezechiel. And so feel free to just send or write down your question at the chat box, and we'll just introduce your question to all the panelists.